Welcome to class on group data. Group data is one of the most underrated topics to understand key things. So in here, we have what we call the class. The class has what we call the lower bound and the upper bound. Then we have the frequency and the cumulative frequency. Now, the class width comes in two ways. There's a joint and a disjoint class width. So one is a histogram and one is a bar chart. So we can have 1 to 5 and 6 to 10. We can have 1 to 5 and 5 to 10. So you need to identify which one is a bar chart and which one is a histogram. So the one that is joined is called a histogram, where the numbers, where it ends starts. This one is a bar chart because the number has a gap of 1. So whenever you have such a parameter, you need to know that you need to adjust it. You need to adjust the classes by subtracting 0.5 and adding 0.5 on the upper bound. So this is just a rule. Because there's a 5 there, there's supposed to be a 5 there. There's a 10, there's supposed to be a 10. So these numbers are not the same. So for you to draw a histogram, you subtract a 0.5 there, which is 0.5, and you add a 0.5 there, which is 5.5. 5.5 to 10.5. 10.5 to 15.5. 15.5 to 20.5. Then we have 20.5 to 25.5. All right. Then I need to mention 3 things here. The class width can help you identify the height or the class width. So the distance from here to here is called the height, which is 5. It is safer to find the distances from the upper bound or the lower bounds, or the width from the lower bound to the upper bound for the group's data here. So the width 5.5 minus 0.5, you get 5. If you don't adjust it and you subtract 5 minus 1, you get a 4, meaning your answer may be adulterated. All right, so this is how we find the height. Then for the frequencies, we have a 3 there, we put it here. We add it to the 7, we get a 10. We add it to the 10, we get a 20. Add it to the 5, we get a 25. Add it to the 3, we get a 28. So this last number here is usually the total of this column, summation of the frequency, which is 28. This is a BID class. I'll need you to ask questions whenever you're lost anywhere behind. Agatha, Sola, so far we together?
Yes, Mr. Collins, I have a question. I got lost on the height. How did we come up with the total 5? Because on the class, we were subtracting 0.5 and adding 0.5, which is, what do you call this? It's like a must, right? It's a principle. But then how did we?
0.5 when you discover
Yes.
that these numbers are not the same. If it is already 1 to 5, 5 to 10, don't subtract 0.5 because it's already adjusted. So here, the height, 6 minus 1 is 5, 11 minus 5 is 11, 15 minus, so the height is what 5, the distance from here.
Okay.
That's the height.
Right, okay. Okay,
Ideally, the height is supposed to be the same as the width, but because this one has an error, it's not adjusted. The perfect one is this one here. From here to here, it's 5.
Yes.
Okay. And from here to here, it's also 5. This is the ideal situation. It can only happen if that number is the beginning number here. You can see 10.5, we're starting from 10.5. So this is ideally the case.
All right, thank you.
Any other questions at this point? right. So the examiner will ask you, maybe at this point, what can you expect? Draw a histogram. A histogram, draw a bar chart, and draw a histogram. We're going to draw the two things here. So if we don't adjust, 3, 4, so 1, you have 0, 2, 4, 6, 8. So we discovered this one with spaces here is what? Is a bar chart. So 1, 2, 3, 5, 10, 15, 20, 25, 30. So from 1 to 5, the height is 3. 6 to 10, 7. 11 to 15. So 1 to 3 is 5. So 1 is somewhere here. 1 to 5, the height is what? 3. Then 6 to 10, the height is 7. So it's not starting from 5, it's starting from 6. 6 to 10, the height is what? 7. 7 somewhere here. Okay. Then we go 11 to 15, the height is 10. So 11 starting from here to 15, the height is what? The height is 10. So ideally, what I'm trying to go through is you understanding the difference between a histogram and a bar chart. So ideally, what I'm trying to say is that for the bar chart, the outcome will be like this. For histogram, the outcome will be like this. Okay, this is how.
Sorry, Mr. Collins. Sorry to take you back. The network was breaking. Just kindly repeat from the first graph of the graph just down, the one we are working on, what you said.
So the graph we are working on has spaces 1 to 5, 6 to 10, 11 to 15, 16 to. So whenever they ask you to draw the bar chart, don't adjust it here because there's a difference between the upper bound and the lower bound. Okay. So 1 to 5, our height is what? 3. The next one is what? The next one is 6 to 10. The height is 7. That's a 7. Then 11 to 15, the height is 10. So we go to 10 there. Okay. Then we go to the next one, which is 16 to 20, it's 5. 16 to 20, it's 5. So 5, there's a space there of 1. 5 is somewhere here. Then we have 21 to 25, it's 3. Okay. 3 somewhere here. So the same graphs will be the same, except that for the next one, what is actually happening? 0. Here we have when you do the line, means that we're not starting from what? From 0 exactly. There's a gap there. It's important that you always understand all these. So this is 0.5, 5.5, 10.5, 15.5, 20.5, and 25.5. So 5 to 5.5, the height was 3. 5.5 just connecting to 10.5, the height was 7. Then 10.5 to 15.5, the height is 10. 10.5, so this is 7, 5, 10, and 5.
Sorry, Mr. Collins, the second graph is a bar chart?
The second graph is a histogram because it's attached. This is called a histogram.
Okay.
Because the bars are attached. Then this one is called a bar chart. Okay. Are we together on this so far?
Yes, thank you.
Yes. Yes, please.
Can we proceed? We now go to filling in this table. So after finding this, the cumulative frequency, we put this one here, we add that. 10. So 10 plus 10, 20. 20 plus 5, 25. 25 plus 3, 28. Then how do we get the x? This is called the midpoint. The midpoint is simply found by adding the lower bound to the upper bound. 1 plus 5 is 6. 6 divided by 2. So it is x1 plus x. In fact, the midpoint is found by the lower bound plus upper bound divided by 2. Lower bound plus upper bound divided by 2. So 5 plus 1, 6 divided by 2, we get a 3. Then when you square it, we get 9. Then you multiply 3 times 3 is 9. So we can call this column 1, column 2, column 3. This is column 1 times column 2. This is column 1 times column 3. So again, there's 3, you multiply it by the 9, we get 27. Let's go. This point here, to get the midpoint, it is 6 plus 10 is what? 16. Divided by 2, it is 8. If you wanted, you could have just added a 5 because this height, you can keep adding the height to these numbers here. 3 plus 5, 8. 8 plus 5, 13. 13 plus 5, 18. 18 plus 5, 23. So you keep doing what I'm saying. 6 plus 10 is 16. Divided by 2 is 8. 11 plus 15 is 26. Divided by 2 is 13. It's the same thing. All right, so how did we get this 8? We added the lower bound plus upper bound and answer divided by 2. How do we get the next number? We square this one, which is 64. And how do we get this answer here? We now start from the frequency. 7 times 8, we get what? 56. How do we get the answer here? Multiply 7 times 64. What do we get? 64 times 7, we get 448. At this point, I'll pause. 9. So to get fx, multiply what?
We multiply 3 by the 13.
Where's the 10 times the 13?
10
10
times
times
13.
Yes, so 130.
Then we
here?
have
How do we get this column? Team members help.
So for that one, we multiply the frequency times the x squared. So it to give us 1,690.
Good. Then here,
Does someone want to try, or I can go ahead?
in your team members, yes, any of your team members?
Yeah, I'm asking.
Yes, yes.
Okay, so let me go ahead. So x midpoint is 18.
Mhm.
Then x squared is 324. And the frequency by the midpoint is 90.
90, so that's the 5
So
times
its
18.
frequency by 18 is 90.
Okay. Any member of the team here?
So,
Mhm.
so frequency, which is 5 by the x squared, which is 324, is 1620.
Okay. Thank you for filling. This is called the frequency distribution table. Frequency distribution table. And there are two other components of this frequency distribution table that sometimes you'll be asked to draw. Is what is called the relative frequency and the relative cumulative frequency. The relative frequency is simply the frequency over the total. 3 over 28, what do we get? We're simply dividing each of them. 3 over 28, 7 out of 28, 10 out of 28, 5 out of 28, and 3 out of 28. So in that order. 3 divided by 28, we get 0.11.
0.107.
And the next one will be 7 out of 28 to get 0.25.
0.25.
Then 10 out of 28,
0.35.
0.36. And 5 out of 28, 0.18.
0.18.
And again, 3 out of 28, 0.11.
0.11.
Then the relative frequency, we can do it in two ways. The way we're doing the cumulative frequency, we just start with this one here, 0.11. You add 0.25. What do we get? 0.36. You add the answer we get here, you get 0.72. We add to this one here, 0.90. And the last one is supposed to be 1.00. Or you simply say 3 out of 28, then you go to 10 out of 28, then 20 out of 28, 25 out of 28, and 28 out of 28. So the final answer must be 1, because it's 28 out of 28. So this is what we call the relative frequency. It goes slightly higher here because we're overrounding off maybe somewhere. But you get the logic. The relative means out of the total. 3 out of 28, 7 out of 28, 10 out of 28. Then for these ones, don't get the total here. You can even start from here. 28 out of 28 is 1. Then we go to 25 out of 28, 0.9. 20 out of 28 until you go to 3 out of 28. Is that clear?
I have a question, Mr. Collins. Why don't we use the total of the cumulative frequency for us to find the relative cumulative frequency? Because I was thinking just the way we found the relative frequencies, we were also supposed to follow the same route when we are calculating.
No. So if you follow the graph for relative frequency graph, looks like this. The cumulative, it ends up to 1. All right. So it starts out of the total here. It's just a procedure. You need to do out of the last number, not the totals. That would be an error. Then now we go to the totals, only things that have an F that we need. So what is summation of F? X and summation of Fx squared. Let's total them up. Sula, are we together? Is Sula there?
Yes, very much. We're together.
Chileshe?
Yes, we are.
Okay, if you're behind, please, you can ask. Want to produce a marking key. So let's get the totals. The ladies do this because you're faster. The gents, give me the totals here. So after getting the summation of Fx and Fx squared, now you need to understand the formulas for group data for the mean. For the mean, summation of Fx be divided by summation of F. This is called the mean. The variance, summation of, the symbol for variance is S squared. So we're going to have summation of what? X squared and a summation of X, the power 2 over N, everything over N minus 1. So Yusuf, I'm giving you the formulas. I will ask you to find me the actual answers. Standard deviation, we're just square rooting what? And also a coefficient of variation. Coefficient of variation, we're going to have the standard deviation over the mean times 100. So I'll give you just 5 minutes to do that. Just substituting the PIDs. Substitute for me. Agatha, Chileshe, and Sula. What do we put here? Three five four
354
over
150
over 28.
over 28.
about here. 5372 354 squared over 28. Everything over 28 minus what?
6.
Minus 1. N minus 1. And the answer you get, you square root it. So I'll give you, was it's an art also to substitute. I'll give you 3 minutes to give me the answers. Let's get busy. So what becomes our mean? What is our mean?
12.64.
4.64. We agree?
Yes.
Yes.
What's the variance?
33.20.
33.20. Do we agree?
Yes.
Then what's the standard deviation?
5.76.
5.76.
76.
Do we agree?
Yes.
Yes.
And what is the coefficient of variation in percentage?
5.57.
It is what?
45.58.
We agree?
Yes.
Okay. So what I'm actually teaching you
I have a question.
is how to put the data in the calculator.
Hello, Mr. Collins. I have
Yes,
a
Mr.
question,
Moses.
if you don't mind. Yes. On the formula for variance, it's x squared minus summation of x squared. But when I look at the values that we have, we don't have a summation of x squared. We have the summation of fx.
Oh, thank you for that. This formula was for ungrouped data. So here we put an F.
Yeah.
Yeah, thank you.
Okay, thank you.
So the variance has 4 formulas, okay? Sometimes you need to know which formula to use. You find some books have a formula like this, x minus mean to the power 2 over n minus 1. Okay? This is also a formula. So you need to take note that there are about 3 formulas for variance under grouped data. So far, I'm happy. Now we go to the mode and the median. Mode stands for the most frequent number. Sula, Chileshe, Agatha, from what I've explained, are we together?
Yes, yes, you are.
Yes, yes.
All right. So the mode is L plus, I'll start with the short method, D1 over D1 plus D2 times height. This one, I know matures want easy things, so let me teach you a short one, then I go to the long one. So to start with, mode stands for the highest frequency, the number appearing the most. So you go here, you look for the number which appears the most, that is called your FM. On top of it, it's F1. Below it, it is F2. Then on the FM, you choose the lower bound L. The L is supposed to be 11, but because this 11 is not adjusted, it's not baptized, we use this lower bound of 10.5. So 10.5. It's the same as 11, but we're looking at what? The adjusted one. So our L is 10.5. And the FC is a number in the cumulative frequency next to the F1, which is FC. Alonjo, what did I say? The first thing to do when you're looking for the mode, Alonjo and Gloria.
The one with the high, you look for the one with the highest frequency,
Uh-huh.
which we label FM. The one above it is F1. The one below it is F2. And then we go to the class where FM is falling and we get the lower bound. In this case, we use the one that has been adjusted, which is 10.5.
Right. Then the FC.
FC is aligning with F1 in the cumulative frequency, which is 10.
All right. So alternatively, after finding FM, the distance between F1 and F2, FM is called your distance 1, your D1. The distance between FM and F2 is called your D2, your distance 2. What is D1? The distance from here to here. D1 is what? 3.
3.
D2?
5.
5.
5.
Your L?
10.5.
10.5. And your height? Height is what? 5. So let's see here. So our L was what? 10.5. Our D1 was what? 3. So 3 plus 5. And our height was what? 5. So what we have here is 10.5 plus 3/8 times 5. So don't touch this guy until you rectify the BODMAS side. So 10.5 plus 3 times 5 is 15. 15/8, what do we get?
1.875.
1.875. When you add these two, what are you getting?
12.3.
4.375.
4.375. That is how we find the mode as an undergraduate. As a postgraduate, post that formula, depending on the book you're reading, you can finalize. It's okay. But the formula you'll be given will be L Fm minus F1 over 2Fm minus F1 minus F2 times height. The L is the same, 10.5. The height is the same, was what? 5. Fm was what?
10.
What is our Fm?
10.
10. Our F1
7.
7.
and our F2
5.
5. Let's see if we're going to get the same answer. Here 10.5 plus 10 minus 7 over 2 times 10 minus 7 minus 5 times the height of what? 5. Quickly calculate this and let's see what answers we're getting. The median is given by FL, then N over 2 FC over FM times the height. So we have our L as 10.5. Our N is same as the summation of F, the frequency. So 28 divided by 2 minus our FC, the one which was in the same line with the frequency 1, is what? 10. So we're going to put 10 minus 10 here over the FM, which was 10 times 5. So we have 10.5 plus 14 minus 10 over 10 times 5. So 10.5 here plus 4 over 10 times 5. So here we're going to have 10.5 plus 2, which will give us 12.5. So this is called our median. We need to know that median means middle. The alternative is find the middle of this. Half of 28 is 14. So you go in here, look for the number which first exceeds 14 or is equal to 14. It is 20. You draw an invisible L here. When you put your 20, the number above 20 is called the FC, which in this case is 10. The number next to the 20 is our FM, which is our 10. Then the lower bound is what? 10.5. It's the same thing that we were doing here. After finding our FM, our F1 is adjacent to the FC. So this is the 10 that I'm talking about here. The rest of the parameters are the same. We just needed to substitute them appropriately. So I said our n is the same as summation of what? EF, which is 28. 28 over 2 is part of the formula. FC is 10, FM is 10, the height is 5, and the lower bound is 10.5. The final answer we're getting is 12.5. That is how we find our median. So I will give you some work to do from the distance paper. You only have about 15 minutes before the lunch hour class. So I will end here. Have a good day.
Thank you.
Mr. Collins.
Thank you.